Okay, now let's look at this problem. Problem number 1402, reducing sizes, dishes. So it's given a chef has collected a data on satisfaction level of his n dishes, and chef can cook any dish in 1 unit of time. So what this satisfaction array contains is the satisfaction level of n dishes. So let's say the dish 1 has satisfaction -1, which means it is not that good, -8, and that is very bad. 0 it's neutral, and then 5 it's good, and -9 is also bad. So what we have to find is uh, maximum sum of lifetime coefficient. Now what is lifetime coefficient? Uh, Lifetime coefficient of a dish is defined as the time taken to cook that dish, including the previous dish multiplied by its satisfaction level. So basically, it is the time at which the dish was cooked multiplied by the satisfaction level of the dish. So also it's given dishes can be prepared in any order, and chef can discard some dish to get the maximum value, which means he can either take the dish or not take. So in recursion we use take and not take funda to uh, get our thing done. So we can use that that if he should at every dish he has a choice to either take this or not take this. And also since here order it is even order doesn't matter, which means this can be sorted. And why sorting has to be done? So if you think about it, if you want to maximize the sum of lifetime coefficient, you have to multiply a larger number to the positive satisfaction level, which means if you want to maximize this you somehow have to keep this 5 at the end of the time. So keeping this in mind, so we shall start coding. But first sorting this. So let's sort satisfaction dot begin and satisfaction dot end. Now after that, we will call a recursive function which will give us the score. Um, we will start by index 0 and time 1, and also pass this satisfaction vector here. So let's write this function which will be written type int, and because it will be index and then time and this vector satisfaction. Now as mentioned, at every point we have to make two decisions, that is to take it or not take it. Now if we take it, uh, we have to add the score of that particular instance. So it will be time at that instance multiplied by the satisfaction at that index plus we will recursively call on the remaining index to get our light coefficient from the remaining array. So it will be index plus 1, and also we have used this one, so it will be time plus 1, and also we will pass this vector satisfaction. And if it doesn't take it, so the time won't increase because we have not taken it. The chef will not make this will not add any time, so we can recurse pass index plus 1 because we will not take this and move to the next dish. Time will not increase, and then that is fraction, and then return the maximum of these both, that is take and not take. And what will be the base case? Base case will be when the index has reached the end. So if index equal to satisfaction dot end dot size actually, then just return 0. Okay. Let's now try and test it if it runs or not. Okay, my bad. Okay, it got accepted, but it won't run on all cases because it will give time limit exposure because uh, it is of exponential time. So it's basically 2 to the power size of satisfaction, that is n. We can reduce this by cutting the steps which we have already calculated. So what are the two variables which determine any state? It's index and time. So we have to store both of this in some form of cache for every answer. So let's make a map. Means you can use time and index also, but I like to use map. Map would take order n log n time for every query, but yeah, it's easier to write. Map there and will be the key value and int will be the value, and at every iteration we will store index comma time, and also we will check if this index and time has been seen before. Then we can simply return index and time. Oh, it should be not equal to, my bad. Okay, it got accepted. Let's try on all cases. It got accepted. Thanks for watching.